We all have baby photos. But can you actually recall that moment? The truth is, most of us simply can't. When we try to access our earliest years, memory often feels like a blurry fragment, a fleeting sense, devoid of concrete details. The hippocampus, the memory storage hub, is rapidly developing in infants. Could this growth actually be the reason we forget? To a baby, everything is novel. The brain is entirely preoccupied with processing and learning about the world all around it. It's strange that we can recall minor events from last week. Yet the first 3 years of our lives are a complete blank slate. From birth, the brain creates billions of neural connections, a process called synaptogenesis, but they are highly unstable. Early memories are often emotional, procedural, or visual, lacking the linguistic structure needed for coherent recall. Although we don't remember the events, that early care and love still form a deep, foundational sense of safety and trust. Neural pathways need to be insulated in a layer called the myelin sheath for fast, efficient signaling. This process takes time to complete. The brain doesn't keep everything. It undergoes a process called pruning, eliminating unnecessary connections to function more efficiently. Imagine memories as books. The earliest ones are written in a language you haven't yet learned how to decipher. The prefrontal cortex, the area governing long-term recall, doesn't fully mature until much later in childhood. Every sensory experience, from the first touch to a smell, is registered, but not encoded as an explicit, verifiable event memory. Learning to speak is a critical milestone. Language is the tool that helps us sequence and store memories chronologically. Even while sleeping, the infant brain is working hard, trying to consolidate and make sense of what was learned during the day. A familiar location can evoke a strong sense of nostalgia, but that feeling comes without any specific, recallable event attached to it. As the baby starts naming things, language centers boom, allowing memories to shift from sensation-based to story-based. The brain is developing so rapidly, like a fast-flowing river, preventing those fragmented memory traces from sticking permanently. Scientists call this phenomenon infantile amnesia, and it remains one of the great mysteries of neuroscience today. Most people only begin to form clear, accessible memories starting around age 3 or 4, a universal developmental landmark. Infants remember how to move and how to react. That's implicit memory. But they don't recall events. That's episodic memory. The formation of new neurons is so high in infancy that it ironically leads to weaker, older memories being overridden and cleared out. It's possible the memories aren't truly gone. They are just in an unindexed drawer that our adult minds can no longer open. A familiar sound, like a specific lullaby, can trigger a profound sense of comfort, proof that emotional memory traces linger. Event memory requires a sense of self and a narrative structure to place yourself as the main character in the past. Hearing stories helps build storytelling skills and linear thinking, which are key to creating stable, lasting event memories. Sometimes, our childhood memories are actually reconstructed narratives based on stories told to us by family members. The brain develops cognitive frameworks, schemas, to organize information, and infants simply don't have enough established yet. This rapid developmental process shows the brain's priority: learning how to function before learning how to detail record. The ability to consolidate memories, turning short-term into long-term, requires the complex coordination of many brain regions. Initially, everything is a sensory jumble. The brain needs time to categorize and sort this input into a clear picture. The amygdala, emotion center, is highly active, retaining the emotional tone, but unable to tag it with specific time and place. When a child realizes they are a separate person with a story of their own, the narrative memory can finally start being recorded. Too much new information every day. The small brain lacks the resources to encode everything into a complete story. The moment a child gains the ability to talk about past events is a signal that their recall ability has been fully engaged. The tracks between the hippocampus and other regions are consolidating, building the freeway for memories to travel reliably. Think of the brain as a computer. The operating system is being installed, and the save function is only turned on later. Physical and neurological growth is the primary focus, consuming all the energy and resources of the developing brain. Even the support cells, like glial cells, must develop to create a stable environment for neurons to perform their memory duties. A specific, strong scent can unlock a powerful feeling from the past. showing that unconscious, implicit memory is intact. We learn general knowledge, semantic memory, early. But personal events, episodic memory, are what gets lost. The earliest memory files lack dates and titles, making them almost impossible for our adult selves to retrieve later on. Knowing who you are, a stable sense of self, is the foundation for anchoring important personal events in time. Even at a molecular level, changes in genes and proteins take time to stabilize the long-term memory formation process. Ultimately, infantile amnesia isn't a flaw. It's evidence of a developing brain prioritizing learning over recording every single detail.
If you find this video useful and want to explore more interesting things with me, don't forget to like and subscribe to the channel. Now, goodbye and see you again in the next videos.